just out of kindness of my own heart. It won't happen much. What'd you say?
Isaiah's sleeping. We're talking about.
We're just assuming he's asleep. I don't know.
We'll find out. Okay. Kurt, are you feel like you're good with machine and scale? Okay. So we got Kurt, we got Corbin, and we got Thomas, and we got Isaiah. So we're gonna get. I called your names, but I want you to hold tight. Stay in a holding pattern. Okay. Until Kurt is done with this one. Okay. So. Just stay in ground effect.
Okay. All right.
Hovering ground effect.
Hovering ground.
Oh, careful. Get aviation instructors involved, it gets a little dangerous. Then you get a theological aviation instructor involved, it gets really dangerous, right? All right. So let's get this up here. We'll get Mr. Kurt up here, and he's going to measure this bolt. And not only is he going to measure the bolt correctly, he is going to write the number, AN number, of the bolt on the board. Okay, so while everyone else was being tortured, we're going to see if he can torture you with holding this still so that you can actually see it, okay? Oh, he's got one, okay. Oh, don't be scared, it's great. You're just the first victim. There's others.
All right. Well, we'll start with the diameter. That's in sixteenths. And let's see here. 1, 2, 3, 4.
It's okay, I'll check it for you.
Yeah. That's harder than what you think.
Lighting's terrible.
You know what? You're just gonna. 1, 2, 3, 4.
That's what
5.
British Airways said, right? Just trust an engineer. I'm an engineer.
And 5. I think.
That's not funny.
Trust me, I'm an engineer. Terrifying word.
5. And then let's check the length here. Oh my goodness. And this is an 8. Wow, that reverse sensing. There we go. So we're at 1 there, so that's an 8.
It's okay. When I'm looking at the GPS approach, I do it the same way. Oh, it said right? I went left. Oh, no, I'm just kidding.
I think it's, so it's 12, so it'd be, 8, 10, 11. I think that is a 12.
All right.
So AN 12, and it has no bolt, so it'd be an absent.
All right. All right, so hey, here we go. Let's see if I can help you here. All right. Okay, my knife, handy dandy pointer. We got 10, we got 11, we got 12, we got 13, and we got 14. Now this one's a little deceiving because it actually gets to the 13. 10, 11, 12, 13. It's actually 14 because it can't not come back here. Look at this. If you went all the way back to here, you'd be significantly shorter. Way shorter. You're taking out 2 threads. So I think it's probably a manufacturer's snafu. Yeah, they probably, it is just a touch longer than that. So we'll say it's a 14. And you're correct with the A, because it's absent of a hole. Good job, Kurt. All right. All right. Mr. Corbin, come on down. mark is here, buddy. So 1, 2, 3, 4. So it's probably a 4. Okay, so that slides back. And the fact that when you hold a 5 up, for example, there's a 5, you see that it's different size here. Okay, you guys see that difference? Okay, so, alright, so it's a 4 and 4 what? Eights here. So 1, 2, 3. That's a true 13. Yep. Correct. Yep. So and 4-13 absent. And 4-13 absent. Alrighty. Next one. Thomas, come on down. Right is right. Alright. You know, right now, know that one? California guy does, right? I was trying to do the prices right.
It's never on the show.
Oh, okay.
Never on the right.
Affirmative, yep. Jordan, are you having fun yet? Hey, did we give him a toy yesterday? We can give him a toy to play with. Here, have a couple toys. And hey, Carter will educate you on these here. Yeah, do you have a? No, boy, Carter, you're not doing a good job so far. Okay, all right. Yeah, I'll give him back to you. Hey, I'll tell you what, I'll ask Shane if you could borrow this for a moment. Hey,
Absolutely.
Jordan, here, Carter has to show you how to use that. Good luck, Carter.
He got it. He got it. No sweat. You're not as good.
Can anybody else see what Thomas is doing?
No.
It's not fair, Thomas, we can't see.
You can't see, Tom.
20 levels under. Oh, yeah, welcome to my life. Whoa. Oh, whoa, that looks like a 1, 2, 3, 4, 5, 6.
7, I'd say.
Ooh, I'm guessing the same, buddy, from here. From this point of view, it's the same. Most of the time. But like, the first one that we did, who was the first person that did it? Curtis's was almost dead on. It wasn't. But then-
Days there. I gotta measure. The first one would be the diameter.
Correct.
In 16.
Correct, sir. Hey, this sets the foundation for all torquing of the aircraft. It's not a joke. It's super annoying, yes. But if you can get it down to where you can do it in a matter of just a few seconds, it will greatly help you. Because if we keep torquing to the head size, not only will the rest of my hair fall out, but lots and lots of bolts will continue to be broken. And lots of students will continue to fail their practicals. Because you're not torquing to the head size, you're torquing to the shank size.
-3.
-3. Okay, -3. Good, thank you, sir. Shank diameter, yes.
And then I already measured this, but I was just doing it backwards.
Yes.
I saw it go to the. I counted it past the 1, 1, 2.
Honorable Mr. Wright, you had a question?
I did. I was kind of confused yesterday about the A and the H. So, just to clarify.
Hold on, we're going places today with that. So if you'll hold your question until the candidates for measuring are done. Hey, what, sir?
I'm a little confused on that.
I'm thinking 17 from here.
17?
I'm thinking 17 from here.
So you're counting it in eighths, right?
Yep, so if you go to the top side of that. it gets to these numbers, okay? When we get to these numbers, we go an AN, I've never seen one, but an AN 3-1, I've never seen one, okay? Thank you, I know you're saying there should be an A, okay? And then we got AN 3-2A, AN 3-3A, all the way up to AN 3 dash, okay, 4, 5, 6, 7, and then what is after 7? A 10. We don't do 8/8. We do a 10. Because that's 1 inch and 0/8. And then an AN 3-11, thank you, I forgot the A, whoever said that. All right, is 1 inch and 1/8. Everybody good? Yes, sir.
If you measure all the way out to the end of the bolt, do you just round it down to the nearest eighth?
Most of the time. Now this is where I said you get a manufacturer select variation, because the AN5 that Mr. Curtin just did actually the thread goes all the way to the end. And so it was actually a 14. I think it would be calculated as a 14, because it wasn't real close to the 13 at all. 1, 2, 3, it's 4. If I go all the way back to here, look how far back it is. See that?
Yeah.
There's no way that's a 13 then. So it's like it can't be a 13. So it's gotta be a 14, but it just barely touches the 14. But there's a logical pattern that comes in here and says, well, it's not a 13. That's weird. There's just no way. Look how many threads are way over there. There's over 2 threads, maybe 2.5 threads. Okay, so there's sometimes that are like, ugh. And if you're not sure, go get a new one. Right? That's probably the safest bet. It's like, well, we'll get another one. Now I know you can't do that with that one that I'm passing around, the honker. You know, it's like, well, I couldn't figure out what bolt it was, so you know, I need an extra $250 for that bolt. Okay, I don't think the customer is going to appreciate that. Okay, all right, I have one here. Let's do this one. And who was the next candidate? Geese, come on down. All right, you can't see. Let's slide it over here so everyone can see. Take a snap. All right, you got to do it over here so they can see you, watch you. Yes, sir.
What kind of life would that bolt have?
I can't remember. I think it's 2,000 hours.
Much older than thought.
Yeah, I think it's something like 2,000 hours or 10 years, something like that.
Do they even NDI it, or is it just a replacement? Time replacement?
Now you do an eddy current inspection, eddy current inspection on the spar. Yeah, eddy current inspection on the spar. Correct. Yeah, on spar.
And you don't have to do like pulls on those?
Pull the whole way. Is that what you're asking?
Yeah.
No, you just do one bolt.
Disconnect the bolts.
Say it again.
You know, like disconnect the bolts and inspect the inside.
No.
It's different.
No, not like the Cessna carry-through spar on the 210 and 177s. So those would have to come out for that new AD. That's a new AD that came out.
Oh, the DC2s you have to do wing pulls that are like 500 hours or 1,000 hours.
Sure.
Yeah.
Just wondering.
Do they not serialize this one?
No. Now, today they will. It'll come with a yellow tag and a serial number on it, but not stamped on it. But it will have a manufacturer number on the side of that. Okay. Usually it'll trace it back to whatever lot it was done on. Hey, Geese, we're getting a little sick here, man. If you'll help us out, there we go. All right, whoa. What are you thinking there, buddy?
It's not quite to the
31.
Dude, the threads don't go all the way to the end there.
Let's see it.
Owen Bank.
Yeah, lots of studying to do.
Yep, 'cause that one's got a pretty,
Study the
long
POH
nub on
form. Study the,
Alrighty, hey, good job. So check it out. He had good rationale. I really appreciate that. Sticking with it there. So this is a bit of a tricky one. If you look at it, there's 1, 2. Whoa, whoa. Oh, right there. Don't move. 1, 2, 3, 4, 5. And 5. Okay, and then with our length. So glad to help you here. Let's go out to a 30. It's got a huge shoulder or nub on the end of it. Look at that. What in the world? That's kind of breaking the rules. Well, it's okay. All right, so come over here and we'll check it. It does not reach 31. There's 31 right there. So it doesn't reach it. If you take away that little nub, boom, we're right at 30. Good rationale, buddy. Good job. And we have a hole. Good.
On the, I always struggle with finding the diameter from the table, which you can with the points at.
Okay. All right, good. So he likes to use the table to his advantage. All right.
On the end where the head is not.
Dun, 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 dun. Everyone nervous? Mike, come on down. All right, Mike, we got a big one here. There it is. Let me erase this side of it because it's getting a little bit confusing while Mike works on this here. Anybody know where the eraser is? Case, where's the eraser?
Trash can, garbage.
Huh?
It might be in that drawer. I saw it in that drawer once. Last I saw it.
Ah. Whoa.
Sneaky.
All right, you got one more after this one, and then we'll get moving, okay? Anybody? Yes, ma'am.
I was just last night. I was like, you know who my baby is?
No, sure no.
He's like an engineer and like builds airplanes, but he has this albatross.
Yep.
Have you ever like experienced one and like
Actually, I have a friend that owns one.
really? No.
They flew it into Oshkosh this year. Yep. Float plane.
Yeah.
Yep. With a big honking nose on the front of it. Yep.
Bartley's on Mike's meeting with us. He's not a real person. I think he's a photographer. Natural.
Did you see this video?
Yeah, it's crazy.
Yeah.
I don't know how he has time to look at this.
Everything's made out of concrete.
Yeah, it's crazy.
It's the way to go.
I think he lives in like, he lives in Marley.
Hey, he was giving rides at Oshkosh in it this year.
for how much?
It was cheap. It's like $35 a seat. Yes, sir. Yep. So, I'm not gonna touch it. You're gonna count. There's 1, 2, 3, 4.
Did you ever have that?
Yeah, good. Perfect.
It's like I can't imagine a better airplane.
Will I teach you that? Eventually. But you may not have them in your shop. So if you know it the long way, you can do it, you know, you can do it every time, right?
Are those allowed during testing?
Which one, sir?
Like the sliding gauges?
If the DME has it, but you're not allowed to bring it.
Oh, you can't go.
And so far, each DME has not had one. I checked. All right, let's check. Let's check Mr. Mike here, all right? Here we go. So, let's go to diameter AN 3-1, 2. Oh, Brian. 1, 2, 3, 4, 5, 6. 6 is correct. Length. Now, hey, if you see this, what do you already notice from this bolt? That it got stretched right here. Look at that. It's narrow right there. It means somebody put a little too much ugga-dugga on that one, okay? All right, but it does have a large nose on it. So
Is that
let's see.
stretched or just damage the threads?
I know not, sir.
I mean, but
I do not. Either it's, well, every time you torque a bolt, it stretches. Okay, true statement. So that is torqued, stretched, and threads are ruined, correct?
right.
Yeah. All right, so we've got a 31, 32, 33, 34, 35. I'm counting 35. Ooh, we did it. But what else is he missing here? An H, right? And nailed it.
What's stage 4 again?
What's the H for? Hole in the head.
For lock work.
Hole in the head. All right. Before I call the last candidate, I would like to show you something really quickly. If you're looking at this bolt and you're looking at this bolt with your eye, what difference do you see?
One's longer.
Okay, great. One's longer. Congratulations. What else, Mr. Jedediah?
Coarse thread, fine thread?
Coarse thread and fine thread. What does that mean? Okay, so fine thread means that we have more threads per inch. More threads per inch. So if this is an AN4, more than likely it's an AN4-28. Does that mean it has 28 threads? No. You guys are geniuses. You can look at this one and say, there's no way that's 28 threads right there. What is that insinuating? That there's 28 threads where? What? Per inch. Nailed it. Okay? But then we come over here and we see this little guy. And we look at that and we say, wow, all right. That has less threads. Now, do you know off the top of your head that this is an AN4-20? No. I told you that. But how would you know? Well, we have cute gauges like this. And you'd say, well, I'm not quite sure how many threads that exactly is. That is. We do realize it's a coarse thread. So you come over here and say, well, hold it up, and it fits like a glove. Okay, see the little teeth? So if you're not sure, you can come over here. Here's a 18 and then the 16. See if the 16 fits. And the problem is it may go in 2 of them, but it won't go all the way in. See? It's not happy. It doesn't fit in there. Okay? Then you try the 18. All right, everybody picking up what I'm laying down?
Ryan, can you describe this as a 4-20? What happened to the length? There's 4 is the diameter.
Oh, okay, good.
Skip the
So this 20 refers to just the thread type. So the thread is not given to you. They're expected for you to look at that and say, there's a coarse thread or a fine thread. And I'll go over that momentarily. Everyone hold on. Okay? So the thread of this one, now it's not expressed. It will just say an AN4 and then the length. Okay? But you as the mechanic have to look at that and tell if it's a coarse thread or fine thread. Okay? that make sense? You have to be able to look at it and say if it's coarse thread or fine thread. And it matters. Momentarily, I'll show you. Yes.
So generally, fine thread is 28 an inch, and then coarse.
It's in the
No,
parts catalog.
I just know that because I looked at it. Yes. So,
It's in the parts catalog, maybe something.
ooh, good. Good, good, good. So when you order it, if you look in the parts catalog,
Just how, you're gonna take a bolt out, say the guy.
Precisely.
And it's like, I'm gonna buy this bolt. But
you
if
buy an
it's-
AN4, that's a coarse thread.
Yeah, but.
When it should have gone in the fine thread. That gets
Yeah.
tricky, especially if it's not expressed in the book. Yeah, it gets super tricky. You have to physically look at the hole sometimes, figure out if it's coarse thread or fine thread.
But it could be different course threads and different fine threads too, right?
Yes, yes. But if it gets tricky, most of the time it'll have its own NAS number. All right, so here's a 28, and the 28 you can see is ultra thin. It doesn't fit in there. But when we come over here to this guy, check it. It fits. Doesn't like that one either. Let's see what we got here. Oh, like a glove.
We don't have to fight like metric.
No, we don't fight metric. Hallelujah. Even though, to do justice, metric makes a whole lot more sense when they do the 1.5. Okay, anyway,
Right.
I'm not talking about it. All right.
Not correct.
So when we get to this type, this is a screw bolt. It's a screw head, but it's a bolt style. Okay? Because it's got the grip length and, yes, just
Sorry, this might be a dumb question, but the way you differentiate screw and bolt, bolts have like the unthreaded portion and they are tapered to a point at the end.
yeah, and it's the way that it's manufactured. Yep.
Okay.
Yep. And typically the screw will go most of the way and have a less grip length. Sometimes a structural screw will have a small grip length for a shoulder on it. Yeah. All right, so when you're doing screws like this, now you have to include the head. Whoa, that was a curveball, wasn't it? That doesn't, oh wait, Brian, turn it over, thank you.
Because of being recessed.
Yes, recessed head, you include it. That doesn't seem fair. That's okay, it's not fair. Okay, so we know it's not a 1 inch. Ooh, it is a 1 inch. Look at that. Right at the 1 inch. 1, 2, 3, 4, 5, 6, 7, 8. So it's a 10. Everybody got that? What's the diameter? Well, I'm glad you asked. Hold still, Ryan. 1, 2, 3, 4. AN4 -10. A. Okay, and it will have its own number, so it's actually probably going to be like a AN525 or something when they get to an internal screw head. Okay, so it doesn't follow the same pattern as the hex heads. Make sense? So they'll come up with a different number. It'll be like a AN525 or something like that. You're not required to know that. Okay, it's just going to be a special one. If it has a special head like that, that's where they're going to list it to you as a long number, like an AN525, and then it's going to go through a number. Okay, so for this moment, when you get to a countersunk or recessed countersunk, it'll have its own number to tell you that. Okay, and then you can go to the manual and look it up. All right. So I've got 2 bolts here, and I want you to look at it. This is a X. You see that corrosion resistant steel? X. Here's your Menards. You see it? See the 3 lines? That is a grade 5 bolt. you're walking around the aircraft and you see these cute little numbers right here, does it fit the hole? Is it a quarter 20 course thread? Yes. Should it be on that aircraft? No. It's not FAA, PMA approved. Okay? If you're wondering what that is, it's all right, just wait. I'm not telling you to do it. Okay? Just not approved for aviation. Okay? This is approved. Okay? All right. I'll show you the same mixture. This is one off aviation. It doesn't have any markings anymore. Yes, it does. Wow, that is barely there. Okay, this is one off the engine. These are exact same bolts, a little different length, same thread. Will it fit the same hole? Yep. But one is from aviation. One's not from aviation. One's from our friend across the street, and one's from aircraft sprues. Okay, see there? Yes, sir.
Price difference between the two?
Yeah, probably about 48 cents and probably about $4.80. Okay. But it's worth your certificate, at least to the FAA. Yes.
So, back to the information that you said, so the head size for different sizes, how do we tell if we have the correct head size based off of the number of the
So
things?
those were countersunk like this. Like this, here. Okay? And so you take the head like this and then, like this and measure it. And if you notice, what did they say was the difference in the head size that the gentleman installed? He installed 30 of them.
Smaller head?
By how much?
Like 246,000. 200 something.
Yeah, I think 230, 230.230, 230,000 of an inch. So you're talking to go from here in. So that's yeah, it's a quarter inch smaller head then, right? 0.23, almost a quarter inch. So you're taking away, you're talking about that much narrower. Okay? Notice that where the head's sticking over. Okay? That one's to 12, so that one would have been to 11 when they measured it. And it actually sticks out quite a bit when you do it that way. I'll tell you what, I'll pass this around, you guys try to measure it on your own. Okay?
So there is a sweet pretty thing.
All right. Hey, I need to give you a break. Why don't you take a break and then we'll come back, okay? How about 5 after? Yes, sir.
I was trying to figure out what was stronger, like windscreens, whether being installed with the screws from the outside or the inside would be stronger. Because I mean, if it's pressurized, you get the pressure from the inside, but we've also got the pressure of the outside air for any aircraft.
At 500 miles an hour.
Right. So most aircraft you said are coming the inside. No, you didn't. No, I was just.
And they're both, I've seen both.
See both.
Yeah.
Yeah, you didn't say that. I was just thinking.
Ryan, I don't know if I'm 100% getting it, so the screw, are you saying the screw is categorized as countersunk?
I have it called AM 525, I'll tell you. But you don't have to, you can look it up, and you look it up right now.
So, like, if they won't call it like a screw head, they'll call it a countersunk head?
It'll just have its own part number. It'll
Okay.
say, like, countersunk head bolt.
Uh-huh.
And it'll say like an AN 525 when you hold it.
Okay.
Or close tolerance, like close tolerance, you'll have an NAS 340 or an AN 173. So it's going to be something very odd. And you may not know exactly what that is, but it'll say, oh, that's not an AN3 or AN4.
That won't be like a typical bolt head, that'll be something else. Okay.
And so that's where it's going to throw, number one, it's going to throw you off. See, clevis bolt, AN 21 through AN 36 is a clevis bolt. You have to know that. to count the smallest one, but you can count the second one. Yes, sir.
First number is the shaft diameter, and then second number is the shaft.
Yeah, I bet.
I measured this here.
And then would this mean, that would be your main responsibility.
Yeah, so on the say? For your enjoyment? Yes, that's what I mean to say. For your enjoyment, I brought the gauges in to satisfy your life, okay? So, I'm not trying to sell. I couldn't care any less if you buy these because now you know how to use the machinist scale. Right? All right, okay, good. Where's a few students?
I'm not quite sure.
Okay, all right. So we've got a gauge here. Check it out. Whoa. All right. So if you're not sure, you can play the guessing game or, bingo. So you come in here, it's like, oh, won't fit, won't fit, won't fit, won't fit, won't, oh, whoa. Slap it in there like that. There you go. So then it becomes an AN 6-35, because it's got a little nub. Beautiful. Wait a second. Isn't that what he already wrote up there? Yes, he did. He's got a hole in the head. Yes, sir.
Is that chart corrected a little bit for little end of the bolt? Or is it?
No, and it's not even perfect. It just depends on whoever they paid to put the sticker on the piece of aluminum here. I'll show you. Okay, you ready? Here we go. Oh wait, it fits there. AN 3-17. Okay, everybody good there? All right, let's find out what my anomaly is here. Doesn't fit a 4. Ooh, doesn't really fit the 4 at all. There he goes. It fits a 5. Oh, it's dead on 13. Isn't that what we measured a second ago? And so this one doesn't have that little nub on it. It's dead on 13. So that one wasn't perfect, okay? All right, let's see what this one is. So that won't fit 3, won't fit 4. Oh, it fits 5. There's AN 5-30. Okay? You like it? But that's including the nub too, Mr. Randall. Okay, but we measure out as a 30 with the machinist scale as well. All right. So there's 3, 4 it fits. There's a AN 4, and that's a 21. It. But good. So this is how you use a gauge chart. Bolt gauge. Pretty quick and snazzy, isn't it?
With that, it should be closest to a certain number. Even
Yep.
that nub.
Yep, so what I'll do is I'll pass this around so you guys can play with it. A couple bolts here. Ooh, I didn't start on this end, so I'll start back here with David. I'll put it on this end. Yes, sir?
I'm not sure if I got this, but would you recommend using that or just?
You can, but you don't rely on it because you may not get it. You may not ever.
So it's good as like a double check kind of.
Yep, yep, and if you have the gauge, it's awesome. But now you know how to use it without it. Yes? All right. Let's go to a table chart or a torque chart real quick. We're going to talk about this on Monday a lot. Not late on Monday, but I want to talk briefly about numbers, okay? Some of it's not going to make sense today, and that's okay, okay? This is out of AC 4313. You'll be using this for the rest of your life. Okay? AC 4313, your chart is on page what? 7-9. 7-9, page 7-9. Okay, so we have Cheddar, this is your question, and so I want to appropriately attack your question. Okay, an AN 4 is a 4 over 16, which equates to a what? Quarter. So here's where you're starting, AN 4. Everybody see that? Those of you, Sam, are you with me? An AN 4 is a 1/4 inch bolt. But now we're going to thread size. Why does that matter? Anyone? Okay, on a fine thread, the bite, a quarter 28, the bite is smaller, okay? On a coarse thread, the bolt is going to have a deeper bite in the hole. Does that make sense? So the quarter 20 right here, or the AN what? 4. I'm not talking about an AN3 or an AN2 yet. I'm only going to deal with the 4 for this moment before we get to mass confusion. Okay? 4/16 is a quarter inch. Everybody there? Okay? Yes, it requires you to do math on the spot. AN4, 4/16. All right, 4/16. 4/16 equals, that's a quarter. Okay? So then an AN8 would be what? An half-inch bolt. Whoa, who's sharp today? All right, somebody sharp. Yes, all right. Nailed it. Okay, just today. All right. So a quarter 28 means that these cute little teeth here are very, very fine, and they're not going to bite as deep. Let me prove it to you. A quarter 28, the torque for that is 50 to 70 inch-pounds. What does that mean? We're not talking about that till Monday. A quarter 20 is 40 to 50 here. Okay, 40 to 50 coarse thread. Okay? So we have 50 to 70 or 40 to 50. Okay? Slightly different torque. Everybody good there? Kind of understanding. All right? More teeth inside the hole for the quarter 28. Okay, down here, quarter 20, 40 to 50. You'll get 30 to 40. Now we're going to get to tension load and shear type. So you actually have to think, where does this bolt go on the airplane? What usage is it? So Kurt is in a 172. He spent quite a few hours in a 172 getting well acquainted with it. On the back of the 172, there's a very useful object called the rudder. We run cables to the back of the rudder, and we as mechanics shove a bolt inside the cable in the eye bolt there. Wham! That's called a clevis bolt. And as Kurt is coming down for landing, especially on a crosswind day, he's fighting the wind with his rudder pedals. Yes, it's a good thing to do. All right, and he's trying to maintain center line, right? Meanwhile, he's yanking on that rudder pedal, or pounding rather, with his foot on the rudder pedal. What is happening to that clevis bolt? It is being subjected to what? A shear load. So you have to think, I'm installing that bolt, and that bolt there is typically an AN4, and it's an AN4-20. But it's not a tension load. It is a shear load. Every time you hit that rudder pedal, it is trying to shear that bolt off. Are you with me? So you have to think. They require you to use that God-given brain and say, that is a shear load on that bolt. Are you with me? Okay. When you install the wing and you torque it stinking 200 pounds, you have to think that wing bolt, even though it's a load, now thankfully, Beechcraft and Cessna all give you the torque for that. Because if it's not listed in the torque, you're going to use the torque chart. Okay? But if it's given a special torque, when it says, installing the wing bolt, please torque this bolt, and gives you the part number, to 250 foot-pounds, that will trump this torque chart. Got it? So, for example, on a gasculator, remind me, fuel systems, what is a gasculator? What's another word for a gasculator? A? Sump, or what's the term I'm looking for? Strainer. Good. All right, good. Strainer. So the strainer, you actually torque the strainer to 20 inch-pounds. but it's huge. I mean, it's like a 5/8. Let's go to a 5/8. And a 5/8, writing's on it today. So a 5/8 would be equivalent to what?
5/8 would be, well, it'd be a 5.
A and 5. Oh, man, he's on today. Ooh. All right, so an A and 5, there it is. Okay, there's an A and 5. And if you were going to torque a coarse thread, A and 5, what would the torque be? 80 to 90 inch-pounds. So what are you going to do to that strainer? Bloop. You're going to break it. A strainer runs about $430. So inside the Cessna manual, it tells you to torque that bad boy to 20 to 25 inch-pounds. So who wins? Who wins the torque? The manufacturer over the torque chart. So if it lists the torque, I'm supposed to talk about this for a long time on Monday, so I'm not going to get too much into it. So, all right, A and 4 is a 1/4-20 or a 1/4-28. A and 4, depending on the thread, okay? And as you work in aviation, you'll be able to look at it and say, oh, that's an A and 3, and that's a fine thread. Boom, A and 3. Well, we break the rules when we get to an A and 3. I know what you're thinking, Ryan, that's not fair. That's okay. That's why I'm not 6 foot, right? So A and 3 breaks the rules. A and 2 breaks the rules. We go back to a screw setting. That's where you get the 1024 or 1032. An A and 2 is an 832 or an 836. Okay? The screw, the way we do screws, like whether they're structural screws or just regular screws that you're putting on the wings of the aircraft, okay? If they're not what we call PK or structural sheet metal screws, they'll be like a machine screw. It becomes 832 or 1024. That is a screw reference. But wait a second, I've got an A and 3. So you have to just know, core knowledge, that a 1032 is the equivalent, or a 10 rather, is the equivalent of an A and 3. It's the only one that you have to know. I don't know if there's an A and 2. I've never seen an A and 2, I don't think, ever. So A and 3 is typically the first size bolt you're going to see, and that's equivalent of a 10. And you just need to be able to look at it to say, is it fine thread or coarse thread? For example, boom, there's an A and 3. Is it fine thread or is that coarse thread? Fine thread. If you're not sure, get your little chart, get your little gauge right here, and you check it with the gauge. Yes, sir.
What is the 8-dash? The A and 3 is the 10.
The 8 is an A and 2 equivalent, but I've never seen an A and 2 bolt. That's why we get into the screw category, which we'll talk lots and lots and lots about screws and how they break all the rules. Okay?
We're going to do that on Monday.
Monday or Tuesday, probably Monday, we're going to get the torque, but please remember that A and 3 is equivalent to a 10. Everybody good? That's the one that you need to just memorize. A and 3 is equivalent to a 10 when we're torquing. Yeah.
Why is it again?
It breaks the rules because they go back to a screw size. Okay? This is the most common two screw sizes, an 8 and a 10. An R8 and an R10. R8, R10. R8, R10. And then whether coarse thread or fine thread. Yes?
Okay. Instead of breaking the rules and hazardous attitude, so we probably shouldn't use those screws.
You're going to see lots and lots of A and 3s. Please remember that it's a 10. Okay? You're going to see thousands upon thousands in your aviation career. Please remember an A and 3, if it doesn't list the torque, is equivalent to a 10. Are you good with that? Thank you. All right. So everyone understands so far the difference between fine thread and coarse thread and shear load and tensile load. Okay? What if you don't know about the application that is being used and the torque is not listed in the manual? How do you figure that out? You could call the manufacturer. Okay? What if they're not sure? You could ask a coworker and say, hey, could you help me try to understand what load is on this particular bolt? Think through it. Yes, sir.
This chart right here, it says, this may be a dumb question, I may have missed something. 5/16 by 24. What if you have like a 5/16 by 20? Could
You won't have a
that?
5/16 by 20.
So every diameter is pretty much linked with a thread count?
Yeah, unless it's a special, like an NAS, which I'm getting ready to talk to you about. NAS or MS number bolt, which will have its own special torque. Okay? For example, the Lycoming crankshaft bolts, yeah, or camshaft bolt, rather. Crankshaft bolt.
So could you figure out the thread count possibly? I don't want to get too deep, but like, if you know the diameter, you could probably figure out the thread count.
Yep, here's what I'll do. I'll tell you what, I will pass this cute toys around, and I will let you measure. You all have a bolt in your hand, and then I'm gonna pass two different styles around with the thread gauge. But this time we're gonna start with Joe. No, let's start going back over. Let's start with the middle right here. That way I'll confuse you with the thread gauge there. All right? And then you guys can check the thread count there, okay? You already know how to check if it's an AN3 or AN4, and then you just measure it with a thread gauge, okay? You still need to somewhat listen to me while I'm going through this, but hopefully that'll help a little bit with being able to gauge how many threads per inch. So what? Gauge, okay. All right, so we have a MS internal wrenching bolt. Internal wrenching. There's an internal wrenching. It's internal wrenching. Okay? So sometimes MS, this is not part of your core knowledge. Okay? You don't need to necessarily memorize this. But if you're looking at AC 4313, I think it's on the next page. It is. Go, if you're on page 77 and 76, it's going to refer to MS bolts. Typically, they're going to be a special number. You'll see an MS number, like a 2004 H9. Okay? You can always go back and look that up, but it's a military standard bolt. Series class number here, meaning what that specific use for that bolt is. H, safetying, meaning it has a hole in it. And then the 9 dash number is the bolt grip in 16ths. Is that painful? Yes, it's painful. Meaning if you're ordering an MS bolt, it has a special application. Okay? Special application. It's not one of those like an AN bolt. 90% of all the bolts you're going to use in aviation are going to be an AN bolt. Every once in a while you'll have to order an MS or a NAS. MS or NAS. If you look at the NAS, where's your AC 4313? Okay. If you look on it with Randall, on the NAS bolt, it will talk about some weird numbers here. I have it in mind. 7-44 paragraph below the torque chart.
7-41. That's what it is.
7-41 page or paragraph?
Paragraph.
Paragraph, okay. All right, that's why. So you'll have this huge range of NAS numbers. Are you looking on with Randall? Okay. You'll have this huge, and when you get to the NAS numbers, close tolerance is going to give you, when you start seeing high numbers like that, for one example, it does not follow the AN reference to it. Okay? It's going to tell you, hey, this is a close tolerance bolt. What is it? What is the purpose of a close tolerance bolt? Randall, what's the purpose of a close tolerance bolt? Yes. It is a tight fit going in. Okay? It's going to have, more than likely, it's going to be in an area where it's going to need high strength, very tight fit, because most bolts in aviation are what fit? Medium, class 3. So when we get to a class 4, it's going to be a super tight fit. Will you be able to see that with your regular eye? Nope. You won't. Okay? So that bolt might be slightly snug going in. Okay? Anybody tried to turn that bolt that I was passing around earlier? This one here? That's a tight fit right there. Okay? That's a very, very close tolerance bolt. It better hold up to the shear strength there.
Those NES bolts are typically class 4.
Typically. I can't say always.
Right,
Ooh,
typically.
I'm sure you'll prove me wrong if I said always. Yeah.
Doesn't it look at like class 4 is the highest fit in their class 5?
Class, okay, that's when you're getting the grades for like, yes. What they're trying to do when you get to a class 5 bolt, you're getting now to NAS numbers, like not following, like they're gonna have their own FA, PMA number because it is a super special bolt, okay, like a wing bolt. Yeah, it's gonna have its own, basically, product number now. I don't want to bog you down right now. We're just trying to generalize the bolts. So the most common bolt that you're going to see is what type of bolt number or reference? AN number, okay? Meaning Army, Navy, or Air Force, Navy, depending on who you like more, okay? Okay, yeah, all right. So NAS, 14th series number, diameter in 16ths, and dash number, bolt grip in 16ths. Why does it tell you the length? Okay. Proper bolt use, the threaded end of the bolt is always relatively blunt. Ooh, I should take that word always. We saw it a little different today. So most of the time, 90% of the time, majority of the time, blunt. Okay, the threaded end of the bolt generally screws into a nut. A bolt has a fairly short threaded section and a comparatively long grip length. That's what makes it a bolt instead of a screw. Even though it screws in, it has a more of a grip than it does the thread portion. A bolt assembly is generally tightened by turning a nut. Are we torquing the bolt or are we torquing the nut? Nut. Good. The bolt head may or may not be designed to be turned. It's true. Okay. Sometimes you're supposed to torque just the nut and you're not supposed to actually turn the head. Okay. Forces. Yes, ma'am.
Like, why turn a nut? Like, what benefit?
Good. Good question. So, you're going to torque the nut. Here we have this bolt right here going through the main spar of the Beechcraft. It is a very tight fit. If I start cranking on this side of the bolt, what's going to happen inside the hole on that wing? It's going to already start chafing it. Okay? You notice this one has not turned. For as long as that one was in the wing, it has very little wear in the middle of it. It was not turning. It was not meant to turn. So if you're sitting here holding that one, you're holding that one in, you're torquing that nut. The nut was meant to tighten down, and that bolt was meant to stay there permanently. If I start cranking on that bolt, it could start wearing that hole just a little bit. A little bit. Okay. Now, if I can't, the rule is, and it is in AC 4313, if you cannot torque to the nut or you can't get to it, can I torque the head? Yes. But you can get to these. They're made to be like that. So that's fine. You don't necessarily want it to wear. You can get, yes, sir.
Why is that the head of the bolt has the internal, but the nut has the external?
Good. This specific application, the bolt goes through and you can get to the nut side. You can't get to the head side. Okay? That's why it's not hexed the hole is so tight that all you can get to it is with a Halkin, there you go, Allen, okay? And so you get in there, you hold it, and the goal is just to hold it dead still, right there. And then inside, if it's inside the cockpit turning that big bolt, then they're able to torque it there because you have room. But you don't have the room.
Is there an advantage to torquing on the outside versus the inside? Is it the more mechanical advantage is having it on the outside?
I'm not sure. Good question. Never really.
So are you talking about in the nut or the bolt?
Torquing an internal torque or versus an external torque?
Yeah.
I don't know. I can't say I've thought through that one. Cheddar, if you think through a little more, maybe come up with some kind of physics on it. Okay, all right, so your wonderful physics, what do we call review? Physics review. So we have compression, okay? Squishing it together, okay? We have a compression load. We have a tension load. There we go, tension, where it is pulling it apart, pulling this way. So if we're using the application of a bolt, it's going to be pulling the bolt, stretching the bolt. Okay? Bending. Hopefully we won't bend bolts. But do you know, those of you CFI, how many, we have 2 CFIs in here? Okay, pilots. Do you know how many bolts hold the nose fork on the bottom of the oleo strut on a 172 or a 182? One bolt. One bolt. Okay? We have a 210 that did a ground loop. Hit the nose and did a ground loop and did the death block. Blah, 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 blah. It was donated here, wingless, heartless, gutless. Okay? We pulled the oleo strut and the bolt held. We landed it on the nose and and it's at the AN4. It held. One bolt holds it on. Talk about a bending load. That bolt was bent when it came out. We had to abuse it to get it out. But one AN4 bolt, every time your students do a nose wheel landing, you just think about the one bolt. And it's not this bolt. It is an AN4, about that long, that holds it on. And me as a mechanic's like, oh no, please hold on. Please hold on. You know, is that a bad design? You betcha. Can we do anything about it? Yes, you can. You can convert it to a... Yes! Okay, there's my buddy in the back. Putting his bid in for tailwheel airplanes. Long live the tailwheel. Okay, all right. Then we have torch and load. Okay, sometimes twisting it. Twisting it. Most of ours in aviation, if you twist it enough, it's going to break it. Okay? And then last but definitely not least is a shear load, where you're trying to pull against the bolt. Maybe the bolt is not tightened all the way. It's just snug. For example, elevator. Remember that thing that you're yanking on while we're taxiing that doesn't do anything? For your elevator, okay? Your yoke controls, as you pull back on the elevator, goes up and down. The bolts through the elevator are not torqued. That doesn't seem fair. Did you know that? On your pre-flight, those little bolts that you're looking at, there's 3 bolts that hold the elevator on. When you grab the elevator, what are we really looking for, pilots? Oh, start throwing sweat on the back of your neck. Yeah, I've done pre-flight before. Oh, okay, good. What else are you looking for, or should be looking for, on the elevator? Okay. What are you actually looking for as you're moving that elevator? It should move with it. As you turn the elevator, it should move. If it doesn't move, it is actually an AD that says that bolt, when you move the elevator, should rotate with the elevator. And if it doesn't, it will bust the bearing inside. Okay? And so what happened over the years, this is going back, we're talking 1940s, where they came out and they said, hey, those bolts are coming out, you better torque them. So then everybody did what? Whoop, torqued them. A few hours later, the elevators from all the the stress on it was blowing out the bearings. And then they came back and said, no, don't torque them. So then everybody left them loose. Then we get something called a flutter. What's a flutter? You get movement. And then they came back and said, oh, okay, we need a little bit of tension on it. So now we're going to have a tension load on it. Well, that's very subjective, isn't it? So when you're putting those elevators on, especially the Cessnas, and we get them tight, you're actually checking to make sure that it moves with the control surface, but doesn't rotate on its own. Now you'll never look at it the same, will you?
Isn't it supposed to rotate inside the bearing's supposed to rotate?
It's supposed to rotate, it's supposed to have enough tensile load that it rotates with the flight control. If it does not, it is illegal. It is too tight. And if it rotates on its own, it is too loose. Yeah. It is extremely dangerous. You'll blow out bearings. We've had several we've had to change because somebody, man, I put it to whatever the standard torque was. Whoa, 80 inch-pounds. And they'll blow out a bearing in no time. Okay? So proper bolt use, we want it to have the correct grip length. Notice where the grip length ends. Okay? You don't want it down here. And you definitely don't want it too short because we don't have any threads really poking all the way through. Okay? Will that bolt hold? Probably so. But as you saw, too short of a bolt could render a windshield popping out of an aircraft. Yes, sir.
So in this scenario you're giving us with the elevator bolt, where they've gone back and forth a couple times, differing their original maintenance manual information. Now we hook here, or 50 years later, working on an airplane, we pull this bolt out and we're putting it back in, right? My go-to would be, 10 minutes ago, would be to go to the maintenance manual. It doesn't have a torque spec, so go to the AC 43. So where are we supposed to be looking for this information? If it's just floating out there somewhere?
Yep. So there's ADs, but this is why actually you're here, man. Is because there are some of those times where it's like, wow, there's no information on this, or the information that you get is extremely vague. And man, I'll be as open and as practical as I can. When we dissect airplanes, and then, so let's just put it in scenario. So here at SMAT, 3 years ago, I created a lab that this group will take an airplane apart, and this group will take an airplane apart, and then you guys switch groups to put them back together, and you're not allowed to talk to each other. What's the purpose of that? Besides, cruel and unusual punishment, the goal is what? To really assemble an aircraft just like I would on the mission field, and have this idea of, all right, I got to go through it meticulously, and there's times that it's going to say, well, how do I install it? I got to go to service bulletins. Now, service bulletin, which you'll find out in Pub's class, is information the manufacturer said useful, but it's not required by the FAA to be given to the mechanic or to be necessarily done. Service bulletins are not required. Now, I've been in court several times with aviation crashes. They are punishable if you don't do them. Why are you glaring at me? Okay? They're not required. Blaine's going to go somewhere because did you have all information available? Yes, it did. And you didn't do it. You didn't feel like it was needful. Okay? It gets very tricky. Okay? So you'll have to. There's times where, for example, service bulletin, you go and look at that and it says the best practice would be to have it rotate with the flight control itself, and that is in the service bulletin.
So there are essentially one-stop shops where we can go check each one of these, and if it's not there, then
Yeah, but I'm only going to make it. Okay, we're going to make it more mired. All right, I'm going to move on, and we're going to come back to it. Okay. Yeah. Somebody else had a question? Okay. No, because you have service letters, you have service information bulletins, you have service bulletins, you have airworthiness directives, which are required, and the FAA says they're from them
on behalf of the manufacturer because something's happened. Okay? Service bulletin becomes required when it's listed in an AD. But a service bulletin's not required unless it's listed in an AD.
By itself.
By itself. Good. Yeah, but man, we're about to add Lycoming engines. I have 1,800 service bulletins in there for each engine. Let that sit in for a minute, huh?
From a legal standpoint, it's so easy for them to just lay in the weeds and dig in.
Again, yep. From our side of it, you know, we've never been at fault. Okay, sure, have there been errors? Has there been problems? But it's never been found where we were negligent. And that's where, from my dad's side of it, again, the airplane crashed in 2004, killed all but the pilot on board. And that was a $58 million lawsuit. One, Continental paid out, not to Dad, paid to the family. But years and years of grief. Yeah, that's one that's really near and dear to my heart. There's a couple others that I'll talk to eventually through the year, but I don't really like talking about them.
That helicopter crash that happened recently, did they figure out why that happened?
I have not read that. Actually, I have not read NTSB reports this week or last week, so normally I try to do it once a week. All right, aircraft nuts. So we have different types of nuts here. You'll have a castellated nut, looks like a castle, okay? Neat little castle. It's made for a cotter pin. Then you have an AN 310, so it's longer. AN 320 is a shorter one, okay? Is a shorter one. Let's go back one picture. Let's go back one picture. Joe, what would we do well, let's ask James, automotive world. In an automotive world, what would you do if you had too long of a bolt?
Washers.
Throw a washer on it. Can we do that in aviation? Sure. AC 4313. AC 4313 tells you if you put a bolt in that the manual calls for it. This is also another one of those elevator ones where you put the bolt in and it's like, oh, stink. Bolt's too long for the elevator here. Well, what does it say you could do? You could put up to how many washers? It is a specific. We are actually told that in paragraph 7-37 under grip length. Are you with me? All right. 7-37. What is the exact measurement? Oh, and this is a FAA written question. You may read it. It's paragraph 7. 1/8 of an inch of washers. Paragraph 7-37. Oh, no, don't do that, because I will totally blow that off, because I can go to an AN 510 or a AN 520, 416L, which is ultra thin, or go to a 416, which is ultra thick. Washer and blow you away. Don't do that. Yeah. So what's the thickness of washers allowed? 1/8 inch. There's your standard. Unless the manual says use one washer here or one washer here. Yes.
That's like across the board.
That is acceptable practice. Say that truthfully there. Acceptable practice. No more. And that's the FAA written. What is the maximum amount of washers allowed on a bolt if it is too long? 1/8 inch. Good. Say what?
Are there exceptions?
To approved data, yes. If it's approved in the manufacturer's manual, yes. Lycoming oil pressure, you're allowed 7 washers for oil pressure. Lycoming manual says it, 7 washers. Can we not talk about that right now? You're allowed 7 washers. Yeah. Oh my word, that's recent thing in June. But you have
You
opportunities.
just made the point that washers have
Yeah. And it tells you, you can use this many, this washer, and then it says up to 7, or times 7, until you reach approved oil
They say
pressure.
what,
Yeah.
does 8 include any washers that are already
acceptable data. Acceptable. Manufacturer gives you approved information. Yeah, you put them like that, yep. All right, so we have castellated nuts. You have regular hex nuts here. You'll have wing nuts, okay? We have locking nuts, okay? We have insane amount of locking nuts in aviation. You don't have to have them memorized. Hooray! Okay? So, don't fall asleep. You'll have, these two are castellated here. What's the purpose of a castellated nut? Either a cotter pin or safety wire. Good. Okay? What application, are you going to ask me what application would you use safety wire on a castellated nut? I'm glad you asked that. Fuel systems. Okay? Sometimes you'll use those with fuel systems. We have a fiber lock nut. You have a steel lock nut. You have a thin, ultra thin fiber lock nut. You have a aluminum solid lock nut. Or maybe it's a stainless lock nut. Okay? Where would the application for a stainless lock nut be? Yes! Oh. What about something really hot? Yes, exhaust. Yeah, correct. Good. Exhaust. Hey, and as you've already become well acquainted with them, 12 point. If you look at these two right here, and you look at the nut, a brand new nut out of the bag, it is like an oval like this. You're like, man, something's totally wrong with that. Yes, and it was manufactured that way. So when you put it on, it's oblong as part of its locking feature, so that it's ultra tight. Okay, and then of course we have what is this one? A shoulder nut, or what they would call, has a flange nut, sometimes called a flange nut, where it actually has a flat part on it. Okay. Good. Aircraft nut identification, kind of, this is out of your book if you want to take a look at it. You don't have to have them memorized off the top. Yep.
If I had a locking nut and then a non-locking nut, how would I know the difference?
Oh, thankfully that's easy. That's the easy part. So, sorry. Locking nut versus non-locking nut. So you see this here? This is a non-locking nut where it wouldn't necessarily have fiber inside of it, or have that little point like this on it. See how it has a little point on it like that?
So if they have a point, or if they have, say,
Or a castellated like this, yeah.
okay, so if their holes aren't like perfectly cylindrical, then they're a lock.
Yeah, most of the time, or a castellated style, yeah.
Okay.
Yeah, and as you put it on, it'll be obvious, and the manual will call for a lock nut, and it'll give you the part number for the lock nut if needed. It's required there, yep. Okay, aircraft nut identification lock nuts. So you have boots, aircraft nut. Weird. Okay, so you have this fiber here inside of it. Fiber lock nut use is meant to be used really one time. As you cut through it, that fiber is meant to hold. If you have to take it off, majority standard practice is just to change that fiber lock nut. Is it required? Sometimes it's not required, but for the most part, if you take it off, good practice is to change that fiber lock nut with a new fiber lock nut. Okay. And where would a fiber lock nut be found? Common place it might be found. Say what? Low heat applications in areas that are subject to rotation. For example, a control surface. Okay, yes?
You use them a lot on autopilot systems.
Good. Autopilot systems, your ailerons, your rudders, you'll use areas that are not subject to heat. Yes, sir?
So that bulb that rotates on the elevator, so this, the purpose that you
Say that one more time for me.
bolt that's supposed to move the elevator.
Yep.
If you compare it to this,
Perfect application, correct, yep. Good. All right, so identification codes, sometimes you'll get to different types of nuts here, where we get to different coding, okay? And the only purpose I'm showing you this, only reason is, make sure, just because it has an AN 310, make sure you order the exact part number that the manual would call for, okay? Yes?
The book says do not use self-locking nuts where either the nut or bolt is subject to rotation.
Self-locking nut, if it's subject to rotation.
So it should not be used on an
Elevator is going to use a locking nut because it's not typically subject to like a vibratory rotation. Let's see. AC 4313, it says unless, you read on, unless the manufacturer specifically has it approved for it, correct?
I'm looking at book 9,
Yeah, so unless it specifically calls for it, which it would call for it there, yeah. Or sometimes at clevis bolt, they'll call for a cotter pin, castellated nut and cotter pin. That's what we prefer. Cotter pin holds the nut from moving really nicely. Yeah. Lots of vibration, steel nut. Let's see, exhaust, lots of vibration. So you're gonna have steel lock nuts on that one, and it is going to be potential rotation there, just with vibration, but it holds it.
We talking more about the numbers later?
Yeah,
Not so important.
yeah. The biggest thing is, the biggest thing on it is, each one has a specific number. So just as we saw in the video, make sure you order the correct number for the ones that you need. Trying to find that paragraph. I'll pull it up in a minute. Yeah, if it's highly subject to rotation, Matthew, majority of the time it's gonna have a hole in the head, for example, a propeller, or it's gonna take a cotter pin. Yeah, or, example, on a piper, they don't use either one of those, they'll use a star washer, which has teeth that bites into the bolt and to the housing that it's torqued to.
The lock washer is a similar thing.
Lock washer does the same thing, but they don't call for it, they'll call for a star washer. Nut plates, countersunk nut plates, or flat nut plates. We use these a lot with housing for the screws. You have a sheet of aluminum, you'll put a nut plate in there, or a rib nut, or a nut plate for the screw to screw into, okay? It takes the place of a nut. There's no nut. This is a permanent, non-removable. Now, can you remove it with a drill? Yes. Can you install new ones? Yes, and you will. But every time you take the panel off, it's not like a nut that you have to loosen both of them. The nut plate should be stationary, okay? It remains on the airplane. Another place, cowling, okay? Everybody good there? Okay, it's like a permanent nut that stays on the plane. Trying to think of an application that has one for bolts. Ooh, I do have one. Brake linings. Brake linings have the threads already in the housing itself, is a threaded portion. So when you screw it in there, it's not expected to remove every single time.
So you're saying this is like a permanent nut. What would be the difference between this, and I don't even know if they're allowed in aviation, but like a literal nut attached to, a piece of metal,
Sure.
like
Okay.
on the backside?
Yeah. Can I make it practical for you? 172s. Okay. Wing panels. How would you get to the nut on the back of the wing panel? You have a little bitty 6-inch panel right here, and
No,
you got
I'm saying like a welded nut on the back.
well, we're not going to weld aluminum to it.
I wanted to resist saying a welded
of aluminum or a hollow piece of steel, we're gonna try to reduce the weight, because, you know, weight is very beneficial to the airplane itself, in reducing the weight. So by doing that, we can reduce the weight.
So, this is, the main benefit of this is primarily weight savings.
And simplicity. You're not having to deal with the back of it. You know, unless somebody's over tightening screws, most of the time these won't pop out. Okay, screw identification, we're gonna get to this more depth on Monday when we do screws and torques. But we have a machine style screw, we have a structural screw, and we have a self-tapping screw, or what they call sometimes is a sheet metal screw. Okay? You have Phillips head, and then of course our reminder about read and prints, our favorites, right? Countersunk screw, you'd see these around fuel tanks, areas that have gaskets, very common area, okay? And then here we have a length grip, and then the length of the screw itself with a round head, okay? Typically, screws with a round head and rivets with a round head are stronger. But why don't we use this on the windshield? Aerodynamics. Why do we use flush head or countersunk rivets on the fuselage? It's not because of the strength as much as it's for the aerodynamics of it. Okay? Or plugging our pressurization in. So we keep the air pressure in. It will fill the hole better to keep pressurization in. Okay? And unless you're in a DC-3, you don't really pressurize a DC-3. Okay. All right, yes?
Why is it stronger? Like what makes it look like bigger?
You have more surface area that's basically out here holding on it, and less, because this one, in order to get a countersunk into the wing, you've got to take away material for it to fit in there. So now it has thinner material to hold onto it, versus you have full thickness of material for this to hold onto. Make sense? Okay. All right, brazier screws, that is a typical structural screw, and the book will call for it. It has a slight flange here to give you more surface area to hold on to something. Okay? All right, so we have aircraft structural machine self-tapper screws, and screws are oftentimes still structural screw will have an X, and it'll be also identified from the manufacturer like this. Most of our screws on our wings, do they have a specific torque? No. Most of the wing panels, you just put them in, and it is just a tensile strength to it. Say what?
Phillips tight.
Phillips tight, yeah, just snug, yep. Non-structural screw, yep. This is the most common that you'll find on the wings for wing panels for inspection purposes. Okay, part numbers, like I said, I'm not going to deal with screws today. I think we're going to get bogged down. All right, other types of washers and nuts. So as I mentioned, we have an external tooth washer, the star washer. You have an external star and an internal star. This is the ones you're going to find sometimes in aviation with our brakes. Okay, to hold it, we have a split washer or a lock washer. This is most of the time what we call a lock washer. This is what you're referring to, Thomas, correct? Lock
Yes,
washer or
regular
a split
washer.
washer, yep. Then you have a regular flat washer, or you'll have a countersunk washer. Where do we use countersunk washers most common? Ooh, pilots, come on.
Like cowling?
Cowling, good, yes.
What's the purpose of the line? Like, how's that?
So just as we were talking about like a lock nut, what's the purpose of a lock nut? Prevent the bolt from loosening. In this case, you don't even want the bolt to turn. So it's going to sit against the head of the bolt here and against whatever it's bolted to, torqued to. And the purpose is, as those teeth bite into both sides, it'll prevent the turning. Good. All right, Zeus fasteners. A couple more Zeus fasteners. Zeus fasteners are almost gone. except for whatever our buddy did in his multi-engine. What aircraft was that? Apache 235, still infamous, painfully using Zeus fasteners for the cowling. Those big, huge, flat slotted fasteners that hold the cowling on there. You remember those? Did you open the cowling?
I was focused on the check ride.
Yeah.
Zeus Bass.
So you'll still see some Zeus fasteners every once in a while in the older aircraft, but a lot of the time we go to cam locks. Cam locks are either a flat blade or a Phillips. They go in and they quarter snap into a beautiful hold and hold. They're spring loaded. They can be changed. Super nice and make cowling so much faster. Yes, ma'am.
You're saying the Zeus fasteners are really big and bulky?
Most of the time, the Zeus fasteners are very big and bulky. I can think of some applications where they're pretty small, but for the most part, cam fasteners are oftentimes very, very small. A lot smaller, man, a lot smaller than the Zeus fasteners. Yeah.
Zeus fastener, how would you even loosen that?
It has a flat slot in it, and then it's got these teeth right here. So as you loosen it, it just bloop, pops out, slides down. But it's a quick fastener, okay? It's not meant, you know, most of the time cowling's probably the most commonplace. Yep. Cam lock fasteners, you'll see them in lots of places. Cowling, baggage doors, you'll see them, battery compartments, things you've got to get to, oxygen covers, yes.
And on the 414, the fuel drain, is that a camera?
No, that is a quick drain. Slightly different, yeah. But it would operate, I guess, more like the Zeus itself. Airlock fasteners, okay, airlocks where they actually go in and they have two nubs here, but the difference between this and a cam lock is they won't have a spring on it. So there's no spring. Okay? All right, other fasteners. Anybody know what this is? Good, I have one. Oh, it's a little cutie too. Right? Pass it around. All right, here it is. Okay, this one runs about somewhere around $60. Yeah. Do I have another one? These are ones I had to install on an aircraft. Oh, I do have a second one. Yay. Okay, I had to install this on an aircraft, an A-23. You may know what an A-23 is? Or A-19? A-19, A-23 is a musketeer, oftentimes called a mouseketeer, musketeers. This is what holds the landing gear on. And basically you hold this with a pair of vice grip pliers and torque the nut until it smushes the inside and it smushes the end of the head off and then breaks. This will break off. Boom! Okay, I'll show you a video on how that works. And the purpose of that is to hold, they'll have two of those hold on to the landing gear. The reason why you haven't heard of many mouseketeers is because it was a terrible engineering snafu. Okay. Do I have? Oh, I have several of the highlights and high locks. Okay, this is not what goes in your hair. Highlights. These are insanely expensive as well. You're going to install these in Christina's class, but I want you to be educated when you get there. What these do? These are structural. They're super strong. You can do this as a replacement into the spar. Pretty wild. Ooh, I have another cute Joe bolt. This is a lightweight Joe bolt. I need to make sure I get all the Joe bolts back to you. Okay? Yes, ma'am. The one on the left is a Joe bolt. Joe bolt. This is not a high lock here. I'm going to show you a video on how to install a Joe bolt because we don't have them around. But the moment I don't show you, you're going to get out into the field where working on historical airplanes and say, that short instructor gypped me, he didn't show me a Joe bolt. So, I don't wanna gyp you, here's Joe bolt, okay? All right, there's Joe bolt, shove it in the hole after you've drilled it out, you hold onto the head, okay? Oftentimes you'll use a wrench, and as you're turning this one, you're holding a wrench to hold that one, it's gonna tighten it off, and boom, breaks off, there it is. Beautiful.
$30 a snapshot.
That was good.
Just trying to weigh everything here.
No, it's not.
It's a lot.
It's always a bummer when you mess them up too. It's like, ugh, why did I do that?
And then, how do you get it out? You just roll it out?
Yes. But do you know the pain in the butt is when you actually start drilling it, and the stupid thing starts turning on the inside. It's like, no. Okay, because that's what I've always found to be the source of frustration for me is when I go, I'll punch it, whatever.
There's gotta be a better design.
That's why we don't see them. But if I say, you're not gonna see them, you get out here and you say, you'll send me a picture and say, guess what you didn't show me in class, okay? So now I did show you a Joe bolt. When the one of you out of the 30 of you that sees the Joe bolt, it's probably gonna be Randall, but when you see the Joe bolt, you'll say, hey, guess what I put in today? Okay?
Where are they used? It's gotta be somewhere where you're not pulling it in the town.
That's right. So I have one. When we get to landing gear class, I'll show you where it goes. I pulled the strut off the one that crashed. I'll show it to you. Yep. These are a lot bigger than a rivet, yeah. Yeah. And you can't get to the back side. So, for example, Cherry Max, but have you ever seen a Cherry Max? This one's a ½ inch. So, as you put the magnesium strut on, so it slides on, and you drill a hole, you put the Joe bolt through it, you can't see the inside. And that's what's crazy. So when you drill the old one out, you pull the landing gear off, pull the old Joe bolt back out, put the landing gear back on, and then drill the next size bigger and put another Joe bolt in. The moment you drill it out, it's going to fall inside the landing gear.
And how many drill bolts would be used?
2 hold the landing gear on.
So if you have to take one back,
Yeah, correct.
Ryan, do I hear this right? So you're saying every time you take out a Joe bolt, the next time you put the new one in, you have to drill it and bigger?
Most of the time, yeah. And there'll be a criteria in the service bulletin by Beechcraft that says if it's rotating before you drill it out, if it rotates with a wrench, you'll have to oversize it. There's a couple criteria that allow you to check a box.
There's only so many times you can do that until,
So you gotta buy another new landing gear.
yeah.
Okay, Stan, you probably, I have to say this very quickly, you probably won't see it. But you know what a Joe bolt is. Okay. Standard process. Today, I'm gonna split you up in 2 groups right now, and you're gonna have the rest of the time for lab, which is not quite 2 hours. Trying to shoot for 2 hours, but we're close. All right, so what you're gonna do is you are going to, you're gonna drill a hole. You're going to tap the hole, and you're going to put something called a helicoil in it. Okay? If I do stand up here and I do one, it does you no benefit. Okay? Our engine cases are made from what material? Grant, do you remember?
No, I don't.
Okay, I'll give you multiple guess. Steel or aluminum?
I'm gonna say aluminum.
Okay, someone else said it for you, but that's great. Okay. Yeah, you're right. They are made from aluminum. So after they're done multiple times, torquing in and out, they pop out. And then we have to put a Healy coil in it, okay? The other year, we had one group set their case on the table. Another student who was talking and joking around ran into the table and knocked the case on the ground. We changed 16 bolts and Healy coils in the back of that case. Still salty about it, you can't tell. Okay, so what happens is, if I want to put a 1/4 bolt in a hole, then I have to go and buy the drill bit for the Healy coil. What's going to happen is you're going to drill it out, then you're going to take a tap. And what a tap does is it creates teeth for the Healy coil to set in. You're going to tap it with the tap, which puts threads inside the material. Then you're going to take the tool and you're going to put a Healy coil in it. All of that is bigger, and it comes in the kit for the Healy coil. Then you're going to get a 1/4. Even though the hole was bigger, the Healy coil fit in there, and it's nice and snug. And then you're going to put that in there, and you're going to torque it to whatever. This is a 1/4. If I did a 1/4/28, your lab is going to call for a 1/4/28, which is a AN4 fine thread bolt. Okay? All right? And you're going to put that one into the hole, and you're going to get signed off. So you're going to drill the hole, you're going to tap the hole, you're going to install a Healy coil, and you're going to install a bolt. Now, the Healy coils that we give you, you will be in charge of measuring. It will say that the Healy coil is for this depth of bolt. So if it's, let's say it's 3/4 of an inch deep Healy coil. Let's ask Shane. Shane, what's the length of the bolts going? Length of a bolt is in 16ths or 8ths?
Length would be 8.
So 3/4 is equivalent to how many 8ths?
Sorry,
6/8. So if you're going to install an AN4-6 into that hole, if it says the Healy coil is good for 3/4 of an inch, if it says it's 3/8 of an inch, that's 3, so that would be an AN4-3. So then you're going to install this is not a 3, can you tell? Anyway, this one's probably 3/8. You would install an AN4-3. Okay? Let me pass out the lab and go over it. What we're going to do is, we're going to let the group on my right do the Healy coils first. Okay? The group on the left over here, this group, you are to be working on lab 2. There's two lab 2s and 2 lab 3s. Yeah? Okay?
Hold the parts one.
Yeah.
What do you mean by two labs that we ended?
There's one that says for you to go out there and there's 2 lab 2s.
There's one lab two, I think.
There's 2 lab 2s.